Yes, everyone.
Reaction of oxide peroxide with alkali.
Reactions of oxide and
No,
peroxide with water.
with what? Yes.
Fine. So that
We
was the
didn't
last one.
start it.
All right. Yeah, I now understood. So fine. So this was the heading, I guess, right? Uh, I think relative stability, I told you yesterday, right? Yes or no? This part I covered. Relative stability of peroxide and superoxide. Did I cover it? Yes or no?
Yes, sir.
Yes, sir. Complete.
Yes, this completed. Okay, thereafter the reaction. Fine. So I will be explaining on right on other notebook. So now what we have to study, because we have already seen with oxygen various uh, types of oxides are formed like peroxide, superoxide and normal oxide. So what will happen if I am dissolving a normal oxide like Na2O in water? So obviously it will form NaOH, right? Now if you want to see that how it is happening, then basically O minus 2 is really powerful base, my dear, much powerful than OH minus. So it basically takes out the proton from here, right, which is in +1 state. This is in -2 state. So it basically attacks over here, and this used to shift. Basically, it takes out proton from here. So if it will take out proton, it will become OH and one negative donated, so it will become on and plus OH minus. This is how it actually happens, right? So oxides, ionic oxides, not covalent, ionic oxides when dissolved with water, they furnishes Na plus and OH minus, which makes the solution basic, right? Very important here is that you can make a note here that if non-metallic oxide do not have ionic structure, right? Like SO3 is having structure like this. There, if you are taking water, my dear, right? There, if you are taking water, situation will be entirely different. It will be like this. This lone pair will be donated because sulfur have vacant D. You remember I told you a dative bond can be formed when a donor atom is there which is having a complete octet and the acceptor atom should have vacant orbital. Either it should be deprived in electron or it should have vacant d orbital also. So it will go like that to maintain the valency, and you can see that HOH, sulfur double bond O minus, and now O minus will take the proton and it will become HOS double bond OH. In short, we used to write this as H2SO4. So isn't it very interesting that the non-metallic oxide, when dissolved in water, it does not releases OH minus, and it basically forms this, which is acid, right? It is an acid. Based on that, we used to say that acidic oxide, basic oxide, amphoteric, and similarly, you can understand amphoteric is the one which will not be even soluble, right? It won't furnish H plus ion, neither it will furnish OH minus, depending on the species taken along with it, it will behave. Like with strong acid, it will behave as base. With strong base, it will behave as acid. Right? I have told you these things, right? So this is non-metallic oxide. This was metallic oxide. This is ionic. This is ionic in nature. And this is covalent in nature. Right? So as you have seen now, the case of, I'm going to delete it, the case of normal oxide, how it reacts. Now, when it comes to peroxide, then Na2O2 reacts with water and it forms basically, see, this thing will be formed, NaOH will be formed. Along with that, you will get H2O2, right? So, of course, I have taken water in excess. So, NaOH is formed along with H2O2 is there. Third thing, if it is superoxide, my dear, I hope you can understand this point. It's not very tough also. Like O2 minus 2 will take out proton. First, it will convert into HO2 minus 1 plus OH minus. Again, it will hydrolyze water and you will get H2O2 plus 2OH minus. Basically, you got 2OH minus now. So that's how it is happening. The way oxide did in the same way. Superoxide, on the other hand, is, just like let us consider KO2. On the other hand, when dissolved in water, again it gives Na, means base KOH. Along with, of course, it will get H2O2, and with H2O2, this is the most important species. Most important species, O2. Why I am telling you, there is a practical use of this superoxide just because of this particular reaction. As you can see that it is producing three important chemicals. One basic solution, another is H2O2, which can be used as disinfectant. O2, is our primary requirement for life. Now you can understand that what might be the use of this. You know the submarines, right? The warships or something which used to be present deep in the ocean, right? Submarine, suppose submarine is there. Can you imagine the situation which is going out there? A person who is at the surface of the water is gifted with the oxygen present in the air. The one who is inside the water, and that too in a ship which is completely closed, not exposed to the atmosphere. So whatever the oxygen content is there here, whatever the content of oxygen is there here, you can imagine if so many people will be there operating that, it will slowly decrease. And to maintain the level of oxygen, we needed this type of chemical which can actually produce oxygen and can absorb CO2, because over the period of time, during breathing we used to take out CO2, and when we are taking breathe in, we are basically consuming oxygen for metabolic processes, right? That will release energy, and that's how we used to function. So O2 will be taken by this and CO2 will be. So the atmosphere of the submarine will be rich in CO2 after some time, deprived in O2. To maintain that, KO2 is used in that, and nothing more you have to do. You have to simply dip it into water and it will evolve oxygen. So atmosphere will be rich in oxygen, and the CO2 which is present out there, that will be absorbed by the KOH, because KOH will absorb CO2 over the period of time and it will convert into K2CO3. Understood now? So CO2, I have written here CO2, don't misinterpret with O2. This is CO2. So please make a note that because of this particular reaction, KO2 is used in submarines, right? Where we do need oxygen. Note it down, guys. Okay. Am I audible? Everything is okay?
Yes, sir.
All
Yes.
right. So thereafter, let's talk about the other thing as well. Yes. So you can see all these reactions I have given anyway. Now, okay, fine. Let's talk about reaction with water. Right? Although it is not new, we have already studied with water. Reaction with water. Right? Now, reaction with water. Because of low sublimation and low ionization energy, they are going to react violently with water. Except lithium, lithium is slow. They will be quite vigorous when they are treated with water. Okay. I will share you some practical experiments also if I'll figure it out on any social media platform. I will send you in your group. Okay. But make sure that you are just looking that only. Do not explore any other thing. All right. So reaction with water. So when it comes to reaction with water, so all of them, be it lithium, be it sodium, be it potassium, and dot dot dot, any one of them are going to react, and you will be getting hydroxide along with hydrogen gas. Aqueous solution, basic solution. Similarly, you're going to get KOH and hydrogen gas will be evolved. Right? And now, if the question comes like, which type of gas is this? Flammable or inflammable? Means something which supports burning or something which resists burning. So this is flammable gas. Means it supports burning, right? So there is a high chance that the moment it is coming out, it may, because it is so reactive and it is coming up with so much amount of energy, because all of them are exothermic, right? Delta G negative, delta H negative, they're quite exothermic. And because of that, there is a high chance of catching fire, means H2 can combine with O2 and it forms H2O. So further heat will be released. That's why I'm telling you it is quite vigorous. The things might even explode. I will share you such experiments if they are done properly, right? I will definitely share with you. You can see the visuals that how it used to react with that. Now, out of them, the thermodynamic tendency or the favorability of lithium into lithium hydroxide is more. You remember I told you, because reduction potential, that means E naught Li plus to Li was minus approximately 3 volt, right? You remember that? Somewhere around minus 3 point something, but near about 3 volt. But sodium was least among its group, but still it was reacting slow, it was reacting fast. So whenever they are talking about yield, okay, means how much product at the end you are going to get. That's what yield means, right? Basically percentage. Yield, when where they're talking about thermodynamic tendency, favorability, thermodynamic stability, all these terminologies are related with these terms. E naught, delta H, delta G. But if they are talking about it reacts vigorously, it reacts slowly, wherever the time frame comes, no? Time frame. Like it happens in quick amount of time. It happens in so slowly, vigorously. These things are telling us about the kinetics of that. So kinetics wise, as I told you, kinetically, sodium is more dangerous. Thermodynamically, lithium is having more reducing power. Okay, lithium do have more reducing power. Understood. So be specific and be careful when the questions are asked. If you can smell a word that is telling you about the speed or something related with that, then think about that sublimation energy and ionization energy sum, which element have lower will be more vigorous, right? More faster. Explosion chances will be there. All right, buddy. Now there is some extension in this. If you read NCRT, they have just given in one line. Okay, that's the beauty of NCRT. They complete the thing in one line. If you miss that one line, now you will be gone. Like if I'll ask you a question, probably you wouldn't have seen that in this way. That, my dear, can you tell me what will happen if I am going to take CH3 C triple bond CH? What will happen? What will be the product in this case? You would have seen this reaction in NCRT, but I can show you the line which is telling this particular reaction. Sodium with this will again evolve hydrogen. This is known as acetylene, right? This is known as acetylene. Acetylene means two carbon, two hydrogen. When that is treated with this, you can expect if it is in excess, then you can replace both of its hydrogen and you will be getting negative and negative. And hydrogen gas. The name of this is given as sodium acetylide. Acetylide. Acetylene acetylide. Another name of this is sodium carbide. So what do I mean by this? Why I am giving this? So you should know that sodium, potassium, cesium are very reactive, including lithium also, but not many uses of lithium is there. So sodium, potassium, cesium are very reactive towards H plus ion. Even if it is not free H plus ion, na, if it is having partial positive charge, right? Even in that case, it will take. So now you will be thinking that, sir, in that case, uh, where from where and where it can remove. So my dear, any of the atom whose electronegativity is good enough, you can say that just like the case of nitrogen, oxygen, and fluorine, or anything which is going to furnish H plus ion. So although this is the limit of this, right? This is the height of this, you can say carbon. Carbon is quite low in electronegativity because it is sp hybridized. The reason it is sp hybridized, and in that case percentage S is 50%, and that's the reason that it have electronegativity nearly 3.23, which is greater than that of nitrogen. So now you can imagine it can remove from here. Not only that, my dear, it can sodium can remove hydrogen uh, from here and from hydrogen of nitrogen as well, like ammonia, uh, NHCH3 if you have taken, it will take out that and it will form CH3, NH negative and Na plus, which is normally said to be amide, right? Along with that, you will get hydrogen gas. Of course, if it can remove from nitrogen, it can remove from oxygen. There is no doubt about it. So you can write many reactions are there with where the H of OH will be removed, right? Sodium is going to evolve hydrogen, and so all the general thing is like that only. So it is going to give electron, and that electron will be taken by the hydrogen. It will leave it negative. So it will be just like that. CH3, C double bond O minus, Na plus, and hydrogen. So like that, many reaction you can draft. I am just telling you a few of them. Like HCl, if you have taken sodium, okay, it's a very good acid, so it is also going to evolve hydrogen gas, right? So sodium and potassium have such a high activity, or you can say in the entire alkali metal have such a high activity that it can replace the hydrogen of oxygen for sure. Anything which is acidic, more acidic than water, right? And even from alcohol, ROH, even from what to say, NH, electronegativity of nitrogen is 3, and from terminal alkyne, it can remove terminal alkyne and can form acetylide, which is also known as carbide if it is sodium acetylide. Both side hydrogen, hydrogen is there. Right? So this is how there is extension of this topic, right? So all of these reactions I have written at one place. You can copy it from here, from OH, from ROH, from carboxylic acid, from HCl, from amine, even from the carbon. But can it remove the hydrogen from sp2 hybridized carbon? Answer is no. Just sp it can remove. Okay, so please make a note. Very, very important. So guys, alkali metals are really good source of electron. You know, if you look at the alkali metal in this way, in many organic reactions, while drafting a mechanism, you will get benefit, right? If you are looking at, if you are looking them specifically this one, the alkali metal as the source of electron, there are many reactions you can solve. I would like to demonstrate it because few of you are already done. Just demonstration for a minute, I am telling you what sort of reaction could be done. You know, when sodium taken with ammonia, lithium taken with ammonia, it reduces benzene into this kind of compound, non-conjugated. Reaction name is Birch reduction, right? So all these things, when alkyne having do not having hydrogen, when that is treated with liquid ammonia, this is one of very unique process. It is the one of probably the rarest of the rare reagent which converts alkyne into alkyne into trans alkene. Otherwise, most of the reductions takes place which converts into cis. This is one among many, which is one among many, you can say, but it is having different stereochemistry, right? It is changing it into. So these things you will understand in future. So in every of these, this method is common, that electron source, it will be taken by this benzene ring and this pi will be broken. You are going to get radical negative ion intermediate, and that's how it, further you are supposed to go through the resonance, and you will be thinking to make them as far apart as possible. So if you are doing that, basically they became non-conjugated, and thereafter they will take proton from either ammonia or either alcoholic sources, whatever you have taken, right? These reactions like that, even in case of ketone also, so many reactions will be there. So I'm just giving you an holistic idea how to approach reactions like this, right? Although inorganic reaction do not have mechanism, I'm just giving you an idea to think about that, right? So which I have already written over here. Now let's talk about, so we are done with reactions with water and compounds having active hydrogen. Active hydrogen means hydrogen attached to high electronegative atom, right? Done till here? Should I move, everyone? Should I move forward?
Sir, can show that point above.
This one?
Yes, sir.
All right, please go.
Sir, we wrote only with Na. It is happening with all Na, K, R, B, and
Ah,
C.
of course, yeah. It is simply a common sense kind of thing, right? It will happen with all of them. Yesterday, I made one point which was really important. You remember, I told you this is probably one of the finest group where all the group member have too much similarities in their properties. See, all of their oxide is basic. All of them are having great ionic character. You go to the alkaline earth metal, you will not receive such things, right? Beryllium hydride is polymeric in nature. Magnesium at different temperature, different structure. Remaining of them ionic hydride. Think about their what to say solubility of their sulfate. Beryllium, magnesium, calcium will be in they will be soluble, whereas barium and strontium sulfate will be insoluble. So you can see the difference in the properties. You will definitely see the difference in properties when you are going in any other group between the among the member of the same group. But here the things are quite similar, and that makes it really difficult to detect that whether it is sodium or it is potassium. And that's the reason I told you that we have to look at the flame photometry or the color of this in oxidizing flame, right? The metal and their salts, volatile salts. All right. Okay, guys. Enough time. Now let's talk about reaction with hydrogen. One very interesting thing you'll see with hydrogen. See, sodium, potassium, rubidium, they are quite violent when they react with water. They very easily react with oxygen. Very easily and quickly, you can say. But with hydrogen, the reaction is very slow. And it will not occur at room temperature. For that, you're supposed to take them at 673 Kelvin with sodium, potassium, and cesium, up to cesium. And lithium requires even more temperature. Can you tell me why is it happening here? Why it is reacting so quickly with water but not here with hydrogen? Can you justify this? You please make a note and think about it. Just I wanted to hear a point from you guys. I wanted to see how you guys are trying to analyze it.
Sir, it forms covalent hydrides.
Which one?
Sir, LiH.
I don't think so. I disagree. All the hydrides of this group are ionic in nature. Yeah, the covalent character will be there. I'm not denying that. Lithium hydride is not covalent. Have covalent character but not covalent. So forget
Oxidation
about
energy.
lithium here. Forget about lithium. Okay, for lithium, if you are thinking that it is requiring high temperature, forget about that. I am asking why even sodium, potassium, rubidium, which are so active, when it comes to reaction with hydrogen, they are so slow. They require such a high temperature, but that thing is not there when they are treated with water. They all react with the cold water. Ice
To
cold भी
break
कर दिया
Bond
फिर भी.
energy of
hydrogen
H.
hydrogen bond.
Sorry.
HH bond energy.
Okay, so you're talking about that hydrogen is covalent, huh?
No, sir. Bond energy of hydrogen is high.
Yes. H2's bond energy is high. That's again, the energy consuming process and which is quite high. You remember the same case happened with nitride also because N2 the bond energy is really high. So that initial amount of energy, who will supply that? So for that we have to heat it, right? And that's why you have already seen that the nitride of lithium directly forms when treated with nitrogen straight away with lithium, whereas the sodium on reaction with nitrogen will not give us nitride, right? I told you here Hydride, on the other hand, all of them are going to form, but just because of the hydrogen bond is strong, so we require to give high amount of energy. That's why we are expected to heat it. H2 is non-polar also. It is gases also. Many things are there. Okay. And lithium is requiring more energy, you can understand, because it's ionization and it is adding more, even it is adding more to the consumable energy that it is going to consume at the beginning. Ionization and sublimation both are higher for it. So that's why you see at 1073 means 800, yes or no? 800 degrees centigrade, it will take place. Rest of them are going to take place somewhere around 400. So just double temperature in terms of degree centigrade. They will take a 400 and that will be at all right. So one reaction which I have already told you in the past also, that ionic hydride when dissolved in water, what will be the case, guys? What are you going to get? Hmm? Any gas you will get when ionic hydride is dissolved in water?
Hydrogen gas.
Which gas?
Hydrogen.
Hydrogen. So basically H minus will be there, which will take, and you're going to get right. Okay. Now if I'll ask you about the stability of these hydrides, what will you tell? The order of stability. Again, it's a matter of, data, but mostly it is monoatomic negative ion. So relative stability you can expect like this. Refer that. My expectation is this: LiH, NaH, KH, RBH, CSH. My expectation is like this. Acha, one more thing I should tell you. Definitely, I should tell you. Uh, although hydrogen is smallest, right? In terms of combining element, it is smallest. But the moment H is converted into H minus, fluorine is quite bigger than that. But F is converted into F minus. H minus is slightly, not too much, but H minus is slightly bigger than that. This is very interesting. In many examinations, they used to ask. The size of H minus is even larger than F minus, whereas the normal size of hydrogen is much smaller than fluorine, right? It will be somewhere around 0.7 angstrom. It will be zero point 0.3, somewhere around that, 0.3, 0.4 के आसपास. Hydrogen. Why is it so, yeah? Why hydrogen size is abruptly increasing? But yes, but it doesn't mean that, it does not mean that the hydride ion will be larger than chloride ion. Of course not. Of course not. So if you want to write somewhere, you can write. Here, I think here I have space. I'm going to just copy it. Note H minus, F minus, H minus, Cl minus, Br minus. F minus, then H minus, then Cl minus, then Br minus. I think you got an idea where you have to place it. Sometimes people used to simply ask about size. Size of the hydride ions. In comparison with the halide ions. And it is not something which you can guess, right? You'll be thinking that H minus will be smaller than F minus. Unless you know the data, real data, right? Might be if you will be looking at, I mean, if you are going through the Ramarao book, maybe you may get this data also. Explore that and try to get that. Fine, everyone. So I have already told you all this. So hydrogen, it is going to evolve for sure. So now if I have to do some, changes in that, like many case, na, isotope of hydrogen, we used to play with that, right? So this is one. Another thing, if I am doing like this, Na, guys, please listen up. NaH, if it is added into D2O, can you tell me what will be the product?
NaOD.
Very good. NaOD along with HD. Yes or no?
DO.
DO क्यों जी? HD होगा ना?
No,
This is, अरे बाबा, do I need to tell you? I will give you a hint. NaH is a source of negative ion. So that is going to take DOD plus. It is going to take this. So what you are going to get? Na plus OD minus along with HD. Only HD. Hydrogen gas. Right? You can play with the isotopes like that. You can, let me change something else now. Suppose if I have NAD and that is treated with D2O, what will happen? Tell me. What will happen, guys? I'll be getting
NaOH.
NaOD plus D2 gas. I hope you're getting it. Yes or no?
Yes, sir.
Okay. So many things. One very important and interesting line about this is, just a minute, guys. Just give me a minute. Very interesting line about this is note. Very, very important. Free, I should not write this. Basically, NaH, KH, right? These ionic hydrides are very powerful base. They will always look for combine with hydrogen in +1 state. Please understand what do I mean by that. Suppose, my dear, please understand. If you have given NaH, ये minus है, here it is plus, so it is going to combine with that. You will be getting, it will be as if sodium is treated with that H2 gas. They are really powerful reducing agents. Right? Suppose if I'm not giving that, suppose if I'm not giving any of such thing means there is no OH. In that case, it is so powerful that it can even take out hydrogen from here. That's why there is a line written in one of the very famous book of organic chemistry, Cledden, that NaH will never behave as a nucleophile. Hydride ion obtained by NaH will never behave as a nucleophile. Those who have little bit idea about organic, they might be knowing nucleophilic thing means attack on the carbon like this. It will never do like that. It will always seek for proton. Okay? It will always seek for proton. But in case of this, forget about this hydride. You take aluminum hydride. That is also hydride. Right. Here, this is going to attack here. It will not take out that. So this is how the whole thing is. Here it is acting as a nucleophile. Here it is acting as a base. See, you can make a comment out there. Means ionic hydrides like sodium, potassium, rubidium, even calcium, these ionic hydrides will never react as nucleophile, means they will never attack on carbon directly. Where will they attack? They will seek for proton. So all those reactions which you have done till now, wherever the proton is there, means you can repeat the whole thing, right? This one. You take NaH here and write down the same product in every case. Sodium is there now, you take NaH. H minus will take this. 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 Take this, take this. Here it will not have any reaction. Neither sodium nor NaH. They do not react with this. So you simply add H and just repeat the whole thing, guys. Are you getting my point? You have to do this with yourself. If you want, I can copy it for you.
Sir, can you show the previous reactions?
What are the previous reactions? This only, no?
Yes, sir.
All right. I'll just copy it for you. Simply write H. See how nice for me. You guys have to write everything.
Sir,
Yes.
so there we wrote CH3CO minus and Li plus.
Huh? O minus Li
Compared to
plus.
Li plus comes.
Huh, actually, you see, this is AlH4 minus, na?
Yes.
So I forgot to take lithium along with that. The actual reason is lithium aluminum hydride, LiAlH4. You'd have heard about it, isn't it? LAH.
Slightly.
Slightly, okay. So even if you are not able to recall this, maybe it will help you. If you can just recall this, it will help you in organic chemistry.
Sir,
Mm-hmm.
if it is reacting with sp3 carbon, can it react with sp2 carbon also, sir?
No, it's not like that. Electronegativity quite greatly varies with that. Specifically with sp, when it comes sp, it have always different impact as compared to sp3 and sp2.
Sir, then last reaction won't happen
No.
if it is NH.
Yes, even if it is NaH. Where sodium can't react, there NaH will not make an impact.
Sir, again this for all metals or only Na and K?
Of course, all the metals, all of these metals, ionic hydride, I
Then we
mean,
wrote only for Na and K no, sir.
as I told you na, many times I told you that
Yes,
these
sir.
two metals will be, mostly in use. So you don't generally write it. Even in the examination also, they're not going to ask you about cesium or something. Have you guys noted it down? That's it? Should I? Everything okay?
Yes, sir.
Fine. Excuse me. Yes. So let's talk about now. We are done with the hydrides, right? Now let's talk about the reaction of the halogens. My dear, when it comes to reaction with the halogen, unlike hydrogen. Why unlike hydrogen? Because hydrogen requires higher temperature na, for reacting with that. But in case of halogen, it is written that vigorously alkali metals react vigorously with halogen. Can you justify this statement? Whereas with hydrogen, it was slow. Right, I should hide it. Okay, that much. Tell me. Huh?
Sir,
Bond
halogens
energy is
have weak
less.
bonds.
Mm-hmm. Halogens have weak bonds, so
It is easier
Electronegativity
to break
difference
the
was.
bond.
all right. They have low bond energy. So go on. They have low bond energy. Alkali metal have low sublimation and ionization energy. Altogether, if we see, we require very less amount of energy to activate them, and that's the reason. Even at room temperature, they react vigorously. So much amount of heat will be evolved. Now, in that, if you want to add those points now, like relative stability and all those, you can add those things, right? Here, in case of halides, I am going to leave certain thing over here. So in these open spaces, you can basically copy all those things. Relative stabilities, melting points, all these things which I have discussed in chemical bonding about the alkali metal halides, you can copy straight away here. Okay, I'm not going to tell again and again. You simply do, but the question can be asked here, and it is more genuine to ask here. Okay, you remember I have given already about the thermal stability, about the melting point, all of these points I have already given to you. So you just go through it and rewrite it over here. So do this exercise by yourself. Okay. Now you have one book also, you can go through that. Now I would like to move to the last part of this, okay, which is last part of the chemical reaction, which is reducing nature. Okay. So I think I need not to tell you that why lithium is having the highest reducing power. Do I need to explain it again? Do I need to explain it again? It is because of E naught value tells, and why E naught value is for lithium, the standard reduction potential is why too much negative. The contributing factor is, the most important contributing factor is hydration energy. You can refer the data also for this, the statement which I have written over here. All the alkali metals are very good reducing agent, including that. So you can add here one point. Although lithium is very good reducing agent, but again the same thing, that with water the reaction of sodium is more violent as compared to lithium. So again same thing you can write, okay. So as per standard electrode potential, right, reducing lithium have highest and sodium have lowest reducing power. Right. Okay, if you want, you can re-add that point. But sodium reacts vigorously with water, lithium reacts slowly. Again, you can add those points, right? So many times I have discussed this. Now uh, let's talk about the which portion should I discuss now? Let's talk about their solution, the solution of alkali metal with liquid ammonia. Okay, solution of alkali metal. Right, with liquid ammonia I should write. Uh, Wait a minute. So now first thing, you know that what is the boiling point of ammonia? Anyone? Anyone? Guys, everything all right? Can you hear me? Is it disconnected?
Yes, sir.
All right. So can you tell me what's the boiling point of ammonia? Anyone? Guys? Hmm?
Minus
idea?
33.34
Minus
degrees.
33.3.
Yeah, ammonia. Now you can imagine below minus 33 degrees centigrade, this thing which I am going to discuss right now. Okay. So ammonia will be in liquid state below ammonia is a gas at room temperature. But below minus 33 degrees centigrade, it is liquid. When alkali metal dissolved in liquid ammonia, then solution becomes colored. Solution becomes colored. And shows excellent conductivity, electrical conductivity. And this solution is very powerful reducing agent. Have powerful reducing power. Really powerful reducing. Can you a powerful reducing solution? You can write it. It is okay. Fine. So let's see that what happens. So whenever the alkali metal like sodium, potassium, any of them you are taking with ammonia liquid, then as usual, as I told you, sodium is having low ionization and sublimation. It goes into Na plus, and please write here Am. Am stands for ammoniated. What do I mean by that? Means Na plus is here, and here it is nitrogen's end which is attached. Are you getting my point? Guys? Yes or no?
Yes, sir.
Like water used to be, na? Just like that. You can just make. This is ammoniated sodium ion. Plus, you can make NH3, NH3, NH3 like that. Okay. Plus electron, interestingly, it is also ammoniated. Sometimes it is written like this, or sometimes written like this: sodium solid plus ammonia liquid. Here they used to write X plus Y, referring the different numbers, right? It will be Na plus dot X ammonia plus electron dot Y ammonia. So all of these things, according to me, is representing this thing only. That the association of that electron if you want to write, you can write. Electron is what? Negative, no? So it is going to attach with NH2, hydrogen of that. You attach it, you do it by yourself. Please understand, I am talking about this one. Got it, guys? Note it down. Now, can you tell me why it is colored? And you would have definitely heard. You would have definitely heard about the color, no? You have read NCERT, no? So the color will be there.
Yes. Deep blue.
What's the color of this?
Value expression deep blue. Blue.
Deep
Blue.
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 Deep. Yeah, deep blue.
Both are given.
Yeah, deep blue only, deep blue. How to make it deep blue? I'm trying to make it blue. Deep blue. Can you tell me why all of these properties are linked with this electron? Ammoniated electron. Note.
It absorbs and re-emits in blue region.
Sorry.
Electron absorbs light and re-emits in blue wavelengths.
Okay. The color, reducing power,
Color
and conductivity is due, all are due to ammoniated electron. But you'd have again read one important point. If the concentration of sodium, is increased beyond a limit, it will turn, कौन से कलर का हो जाएगा? Tell me, which color? Bronze. Yes or no?
Bronze.
BRONZ or what?
D.
Huh?
Z is
Zd, bronze. My dear, I forgot to add one more important point. Not only color, reducing its power, conductivity, and it is paramagnetic also, my dear. Yes, that's also very important. And its paramagnetic nature are due to ammoniated electrons. If the concentration of sodium is increased beyond a limit, it will turn bronze and solution will turn towards diamagnetism. Now, this is interesting. So, if we are increasing more and more sodium atom, why the color is changing from this to that? And of course, these two things are linked. Why it is becoming diamagnetic? Anybody?
Sir, clusters are formed.
Clusters of what?
Ions, sir.
So, what will
Metal
happen?
ion.
So,
Sir,
what
it
will happen?
will.
And first of all, why it is paramagnetic? Because we know the paramagnetic thing occurs because of unpaired electron. Sodium do not have unpaired electron when it comes Na plus. Na plus do not have, na, buddy? Yes or no?
Yes, sir.
And ammonia is anyway diamagnetic. So this is becoming because the electron which are released, na, they are not paired up. And interestingly, it is something which is going beyond the scope right now. Whenever the ammonia, so many ammonia used to, surround that, this electron is under the influence of now the molecular orbitals caused by these many molecules. Now, till the time concentration is low, there is only one unpaired electron in every of these orbitals, molecular orbitals. But the moment you are increasing more, there is a chance of pairing in that. So this space is now a molecular orbital where the electron is occupied. So that ammoniated electron, the space which is created by so many ammonia, is now became a molecular orbital kind of space. So if you are increasing more, na, in that molecular orbital, more electron will enter. Basically, it will become paired up. So उसके बाद भी increase किया तो it can't have more than 2 electron ना, so it is meaningless. So इसलिए मैं बोल रहा हूँ कि it will become diamagnetic in nature. So pairing of the unpaired electron takes place in the molecular orbital caused by so many ammonia, because that these kind of orbitals are not there in our syllabus. So that's why we don't discuss this. We simply write the statement as plain as that the color will change bronze and it will become diamagnetic. But I hope you understood my point, okay? Yes or no? Guys, such a dull response. Did you understand? Okay. Fine. Fine, everybody. So, ammoniated rest. So, most of the properties of these things are over. Now, there are few things like we have to study about NaOH. You guys complete by yourself. NaOH, sodium bicarbonate, sodium carbonate, right? These chemicals are there that you are supposed to go through. So, this is the last topic which I will try to cover tomorrow. But from your end, you do it. Okay, don't wait for my turn. So that's all for now, everyone. You guys can.
Sir,
Yes, let me first
are
stop
we
the
also
recording.
supposed to go through biological importance?